quickly, there was a question that was asked today. I think we can start from there. It's very important. Hi, Bumi. Welcome. Let me try and open it up so that we can. I think it's important. It's on navigation, calculating min lat, d lat, especially min lat when you are moving between the latitude hemispheres. So somebody sent me a message. They were not very confident about the answer. I think they mixed it up somewhere. That min lat is adding the two together, the two positions, and dividing it by 2, you know, like mean. So mean of anything. Felix, greetings, welcome. So let me bring the question out, and which I tried to explain. I don't know if it might help someone as well today. Yeah, I know we had some running also in the group on, what's it called? On Rendezvous. Rendezvous was yesterday. And today we also had a discussion on, what's that called? Limiting latitude. For those that were in the group that saw it, I think that's the OW group though. Did you guys does everybody understand, or is there any need to explain it again?
Yes, I think we need more explanation on limiting.
Of which one? Is it the rendezvous or the limiting latitude?
The limiting latitude, sir.
Limiting latitude.
Limiting latitude. Okay. So let me bring this up first while we're waiting. So if once Captain Danladi comes in, please you guys should just let me know so that I give the space for him. Okay. So this I'm trying to do is just to let me first bring up the share screen. And that's photo. So can you guys see my screen?
Yeah.
So yeah, it's a calculation, right?
Yeah, calculations.
Okay, so the question is about calculating min lat, especially when you're going from one hemisphere to the other. Is this because most people just had the two positions, so the latitude. So let me give let's look at this. So 4.2, if you can see the screen with the screen, 4.2. This is my mouse. So if you look at the question A is on latitude in the north, 10 degrees 26 minutes north, and B is 30 degrees 50 minutes north, right? They're in the same hemisphere. So when you want to calculate the mean of this one, you can add both together and divide by 2. It makes sense, right? B is on south. You can add as well and divide by 2. You get it. Now, this is the tricky part. When it goes from north to south or south to north. At this point, please, how do I explain it? If you add it together and divide by 2, that is not the answer. You start this. And I think if you have a piece of paper, you know, I like to draw because I don't like people to cram. Once you cram and something happens in the exam hall, you start sweating, you know, even though there's AC, you'll be sweating. But if you have a basic understanding of this love example, for example, as I'm saying, you will be able to do it without even 10 years. I've not done this calculation in a long time, all right? But I can still remember it. So the easiest thing to do, I know there is an explanation here, but I won't go to that explanation first. The easiest thing to do is to draw it. So if you have a sheet of paper in front of you, you can take, the equator, draw the equator line, which is a straight line, put 0 there, go then find the points, put 20 degrees. I'm working on C now, 19 minutes north, up of that's north, and go to 40 degrees, 29 minutes south. That will be south. Now you want to look for the mean, the medium point of these two positions. If you add them together and divide by 2, does anybody want to work that out? What will you get? Just looking at it, I think I'll be getting something like 30 degrees and almost 20 minutes. That will be my difference. Right? Hello? Hello? Okay. So you're going to get about 30 degrees and about 20 minutes, roughly, okay? Now, if you write that down, that would be a fail. That would be a principal error anyway, because that's not correct. So what you get, it's easier when you draw it down. So please, guys, if you have a piece of paper, sketch it out. Now, the medium point you get, how do you really give it a name, is apply that medium point, because you're heading south now, right? Maybe to the first one. Apply that to this and see what will be what you get. So if you apply 30 degrees south to this 20 degrees, 19 minutes north, you realize that you will be coming all the way south. You get to the equator and you stop at somewhere 10 degrees 5. Okay. It is important that when you have this question, don't get too excited and say, mean latitude is that you will be wrong. It's going to be principal error and it's going to be wrong all the way. Okay. Same thing if you are at D as well, south to north. Think about it very well. Then if you feel you're getting confused, so people don't like numbers. Once you just see numbers, you just start shaking. All right. Put a sketch it out, spend a minute to sketch it out and you will be able to get the answer. All right. So that is one way of doing it. In this book, they said if the latitude are the same, add, divide by 2, finish, and retain the name, of course. If the latitudes are different names, subtract, divide, they said subtract, then divide by 2 and retain the name of the larger one as illustrated below. It's the same thing, but I just like, the easiest way. This, if you forget, subtract, divide by 2, you've already started confusing yourself. It's correct, right? But that's my own way of doing it. Okay. I think
inert gas systems. So as we are all aware, inert gas system is a very, very important gas in tanker trades. So let me say, without inert gas system, it is impossible actually to load cargo on tankers of certain deadweight tonnage. So that stresses the importance of inert gas. So as at the end of this lecture, you should be able to understand inert gas, the regulations that are applicable. And also there are some incidents. I got a snapshot of some incident that has happened in the past as a result of failure of inert gas or people not following proper procedure. So we are going to discuss that in details. And as we go along, if you have any question, you can stop me at any time. I will be more than happy to respond to you. So inert gas is applicable to only tankers. So historically, inert gas is like a flue gas. It doesn't support combustion. What it does is that it reduces the oxygen content to a certain level that it cannot support combustion. So if you are transporting crude oil that have vapors, so the three things must be put there. You must have sufficient fuel, which is so, but inert gas is being put as a safety precautions on the ship to prevent explosion. That is a basic functionality of inert gas. So generally, it avoid combustion and explosion of petroleum gases, when it meets with steel. And the objective of inert gas is to reduce the oxygen content level in cargo tank below 5%, as well as the lower explosive limit below 11.5%. So if we do that, it's going to prevent tank explosion. So as you are aware, inert gas is not only used during loading. It is being used during discharge operations. We use inert gas as well during gas freeing. In the oil trade, you use inert gas during crude oil washing, because during crude oil washing, there's tendency for you to generate some sort of sparks. So if the oxygen content is not below 5%, that might lead to explosion. So it's very, very important. So let's go to the next page. Now, normally, as you are aware, hydrocarbon gases are normally transported in oil tankers, okay? So generally, they cannot burn in an atmosphere that contains approximately 11% of oxygen. So meaning that they are in an inert condition. So at all time, you have to ensure that the vessel is an inert condition with oxygen content below 11%. But this has been changed because there was an amendment to the International Convention on Safety of Life at Sea, SOLAS 74, which required that the inert gas system, should be about 5% instead of 11% before. So it's very, very important. So now, which ships are required to be fitted with inert gas system? So according to SOLAS, the requirement for inert gas system, it was developed by IMO and it entered into force in 1980 or thereabout. So it required that vessels of 100,000 deadweight tonnage and above should be fitted with inert gas. But this changed 1 year later after some smaller tankers were involved in explosion, and you have loss of life, loss of cargo, and then loss of assets. So in 1981, the IMO amended the regulation and required that all tankers of 20,000 deadweight tonnage and above should be fitted with inert gas system. Okay, so there are some changes, like I said earlier, that has happened, when it comes to the requirement of inert gas system. So as you are all aware, and this question do come up in orals, with effect from 1st January 2016, all tankers of 8,000 deadweight tonnage that carry low flash cargo, that is at 60 degrees C, closed cup test, so must be fitted with inert gas. Prior to this, as I told you earlier, only oil tankers of 20,000 tonnage and above that were fitted with inert gas, but with effect from 1st January, even chemical product or bunker barge that carry low flash cargo must be fitted with inert gas system as part of fixed fire system. So in January 2016, apart from this new requirement for all tankers of 8,000 deadweight tonnage, we also have a requirement for oxygen limit in the cargo tank that came into force. It required that the oxygen limit previously was 8% and it has to be lowered to 5% for the new system. So these are some of the changes that have taken place in terms of inert gas. And I want to let you know that during your orals, so any question that is being asked concerning inert gas should be treated as a critical question. because inert gas is part of solars, and solars is a critical question when it comes to oral examination. So it's very, very important that we understand the requirement of inert gas system, the oxygen content. And sometimes my colleague was asked during his oral question to give the different alarms. What are the different alarms that come up? So as we go along the way, I'm going to explain all this in details. So I told you that we are going to see an analysis of accidents that happen on oil tankers and chemical tankers from 2004 to 2015. So now, if you look at, this is a study that was conducted by SICTO in conjunction with International Chamber of Commerce and OCIMF. So they just took some analysis of about 35 or 36 incidents as such to see what happened. If you look at column 1 here, tankers of less than 8,000 deadweight tonnage carrying oil cargo, they have an explosion during tank cleaning operation. So meaning that the requirement of inert gas as per then between 2004 and 2015 did not stipulate tankers of 8,000 deadweight tonnage to be fitted with inert gas. So if you look at it, as you are aware in maritime industry, for every major disaster or incident that happened, it leads to some changes in international regulation or international convention. So I guess and I presume that this incident, if you look at most of the incidents here, involves tankers of 8,000 deadweight. You look at some during gas free, some during loading, and some are between 8,000 to 20,000. So that's one of the reasons why the inert gas regulation was reviewed in 2015, and it was implemented in 2016, that all oil tankers of 8,000 deadweight tonnage carrying low flash point cargo must be fitted with inert gas. So if you can look at some of the incidents here, some of them are actually as a result of deck maintenance. You can look at it. Some of them are during decanting of slope time when you are moving some dirty cargo from main crew to slope time. So it's very, very, that shows you how critical the inert gas system and the inert gas plant can be. So, and then sometimes the consequence. Failure to comply with this can lead to a catastrophic event, because when an explosion happens, it leads to loss of life, loss of properties, and the more of it is pollution, because you are going to be on the headline of the news all the time. So it's very, very important. So let's get going now. Inert gas system. Generally, how do we generate inert gas system? We generate inert gas system in some ships from flue gas from the boilers. So, and then it's being washed, cooled, and exhaust gas produce the inert gas system. So I'm going to take you through the processes from when you get it from the uptake, from when it goes to the boiler, from when it goes to the scrubber and the fans and everything. I'm going to take you along that part. And then this inert gas, when it is being produced, the oxygen content should be between 2 to 4%, and the carbon dioxide content should be between 12 to 14%, and the nitrogen content is 80%. So as you are aware, nitrogen is also a noble gas, or I would say an inert gas system. So we also have an alternative to the flue gas from the boiler, which is an inert gas generator. So some ships have an alternative, which is inert gas generator. So you can either generate inert gas using flue gas from boiler, and when the ship does not have sufficient flue gas from boiler, then it means you have to use the inert gas generator. So it's very, very important for you to know all this. So this is the typical inert gas generator. This is how it looks like. We have now different designs. Some are being designed by Atlas CoC, You know, some are designed by Mine Diesel. We have different manufacturers, and different manufacturers will also have different look, but this is just conventional. So this is another picture representing the standard inert gas generator with the complete arm. You know, they have the fans, the fuel pump, the dead water seal, the PV breaker. So from the beginning here, you can see you begin to generate the inert gas. When you generate the inert gas from inert gas generator, it goes, there's a fan that push it, you know, it goes to the air fans. From air fans, it goes where it's being washed and cooled, and it's being sent to the dead water seal and to the PV on deck. So the idea of the PV is to prevent the backflow of IG back. So it's very, very important. So as you are aware, the previous regulation required that the oxygen content in cargo tank is to be maintained at not more than 8% by volume. That is the oxygen content. It's not the amount of oxygen being sent to the tank. So there are two different things entirely. So at all the time, a tanker must be on inert condition. And one of the conditions is the oxygen content must be below 8% by volume. So this is a conventional inert gas system if you are in a tanker. So this is the conventional inert gas system. What happens? You have boilers, you have uptakes from boilers. So from boilers, you know, it goes to a scrubber because the gas is quite hot, where it's being washed and cooled. And how does the scrubber work? There is a seawater pump, you know, that is connected with your ballast water system. So if you are doing, let's say you are inerting before gas freeing, or you are trying to poach, so the ballast water system must be running. That provides water to the scrubbers. So once the gas is being washed and cooled in the scrubbers, it's being sent to the blowers. The two blowers, they dry it, and then they send it to the dead water seal. And you are aware the dead water seal is it has a kind of I would say additive anti-frozen liquid inside, so it prevents the backflow of IG back to the system. So it's a one-way form of system. It has a non-return valve. So from there, from the dead water seal, the IG is being sent through the valve, branch valves to the individual tanks via the PV breaker. So it's very, very important. Then you have what we call the vent riser. So if you are loading and when the pressure is too much, you release some of the excess gas through the vent vent riser. And some tankers, I have to stress this, some tankers that are less than 8,000 deadweight tonnage or some bunker barges, they don't have this vent riser, because vent riser is also a requirement for a certain line of tankers. So these tankers are fitted with PV. So you have to go in and open individual PV valves for tanks, i.e. some chemical tankers like the Framo type of vessels, you know, they operate this kind of system. So it's very, very important for you to know. So like I said, it's from the IG main line now, it's been sent into the branch line and to the tanks. So as you are aware, when the vessel is going to load, one of the requirements, maybe if you have been asked in oral, what are the safety requirements? What are the safety checks that you conduct? One of the most important safety check is to check and ensure that all the branch line from the IG main to the tank are open and are locked to prevent accidental shutdown of the valve. So it's very, very important. So very important. Like I talk about the PV valves and the vent risers, they are all here. It's just a pictorial diagram. So this is the scrubber. This is how it works. The water spray wash, as we have all discussed, and it's sent to the blower. Okay, so it's still about the pressure going into the tank. You have the regulatory valve, and you have a no-return valve, like I said, through the deck water seal. You have the main deck isolation valve. And it's very important when you are running an inert gas generator, or if you are running the inert gas system with uptake from boiler, you need to check the system. It has to be on inert gas mode. Some of them are not in inert gas mode. You have to put it either on gas-free mode or inert gas mode. So it's one of the checks that you have to make. And prior to arrival pod, you have to check all your alarms, ensure they are working, the valves are working, all the cargo system are working. You have to clean the screen, the flame screen, ensure everything is okay. So this is still the same diagram that we have discussed. This is about the deck water seal, so that I can't take much of your time. So here it's just like when the inert gas is coming from the engine room, as we are aware, there's it comes in through the water, you know, and it goes in to the individual tank. So one of the major functions of deck water seal is just it serves as a barrier in the system. So it prevents inert gas being delivered to the deck from flowing back, you know, to engine room or whatever. So that's a major function of deck water seal. So the examiner might ask you to explain the inert gas system, and the basic function of inert gas is very, very important. You know, it's very, very important for you to understand the basic functions of deck water seal. So it was a video, I think I wanted to show you, but it's not allowing me, so we just move to the next thing. So my sincere apologies for that. I prepared a video on how the inert gas is moving, but it's trying not to respond. So then you can see how it works about the pressure vacuum breakers. You have a setting. When you have a PV breaker, if you are in the LNG trade, you know, it's like you are relief valves in the tank. So what's the function of the pressure vacuum breakers? When the pressure is extremely high, you know, it lifts. You have a form of pressure relief system to release some of the gas that will prevent the tank from maybe over-pressurizing, which can lead to tank explosion. And when the pressure of the tank is very, very low, you know, it can draw vacuums also into the tank. So that is a basic function of pressure vacuum relief. You know, so if you go to different ships have different settings. So this is just an extract. It's not from, it's not something that is conventional to all ships. So different ships have different settings. So it's very, very important for you to know the settings. So if you go to your cargo operation manual or deck operation logbook that have to deal with cargo, SMS, all the settings are there. You also make reference to individual PV breakers, manual guides, and they contain all the settings. It all depends. So, and if you are new in a different type of tanker, the way the LNG relief valve works is totally different from the way the crude oil valve or the chemical works. Some of them are fitted in individual tanks, while some of them are not. It all depends if they have a common system. So one of the very most important, crucial thing you need to know about IG system is about alarms. What does alarms tell us? Alarms tell us that when something is going wrong. So when something is going wrong, the alarm is going to alert you. I'm going to quickly take you out of this inert gas just to give an illustration of two global incidents that has happened. So you are quite aware of the Texas refinery explosion. So what happens here is they were producing oil and they are putting into the tank. And then when the tank got filled up, you know, there was no alarm system to alert it to cut off. So that leads to overflow and leads to explosion. It leads to loss of damage, reputation of the company, loss of assets, loss of life. So if you also look at the incident of Piper Alpha disaster, first indication of alarm, the pressure pump, one of the pressure pump was put out of service. but there was no tag and a lot of things. So even though most of these accidents are attributed to safety culture and failure in management system, but you can still see that alarms cannot be, you can't overlook certain alarms. The importance of alarm, maybe if you are sleeping at night, when something goes wrong, the alarm is going to indicate that an alarm is going to wake you up. So it's very, very important. So in inert gas systems, some of them are fixed with portable, and while some of them have fixed, while some of them have portable means of alerting. In smaller ships, they have portable, but in bigger ships, you have the same fixed alarm system that is in CCR. You also have it just by the inert gas generator is there. What are the various alarms that it shows you? It just shows you when you have failure alarm, generally is there, number one. When you have high oxygen content, okay? When you have high H2S, it all depends on what you are doing. And when the oxygen being delivered in the tank is, sorry, pardon me, it's not H2S, the hydrocarbon content. So when oxygen being delivered to the tank is more than 5%, and you have to set it at 5%, so it gives you alarm. There's also the pressure alarm. When the pressure is very, very low, it also gives you an alarm. So it's very important. Alarms, sometimes they can give you both audible and visual alarm. The audible come in form of flashing of light. I mean, the visual comes in form of flashing of light, while the audible give you a system. Sometimes when these alarms comes, they don't take time and the entire system will shut down. So it's very, very important for you to attend to these alarms. So sometimes they might be false alarm, but no alarm is false. So you have to be very, very, very extremely careful when it comes to alarm system. So, and for the purpose of oral, you need to know the type of alarms, you know, that you can find in an IG system. Here you can have scrubber water supply. So when you have a low flow of water pressure, an alarm you have an alarm. When you have a very, very low flow of water pressure, it's going to give you an alarm. And sometimes this can actually shut down the inert gas generator because it's not having sufficient water to clean and wash, you know, the flue gas. So it means that the temperature is very high, it's cooling, so it's going to cause overheating. So it's very, very, very important for you to know. So sometimes also the alarms can be low or they can be high. So, you know, as there's a common saying, too much of everything is bad. So when you have a high water level, it's also going to trigger an alarm and it shows that something is wrong. So you need to understand and check. You need to check the discharge valve, how it's been monitored. You have to reduce because it's a ballast line system you're using. So you also have a blower discharge alarm, which is very important. It's reads the temperature, high temperature, low temperature. Sometimes when you have high temperature, it automatically shut down the system. So it's very, 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 very important, you know, for you to know this. So you also have the blower discharge pressure alarm. So there's a pressure gauge that is always fitted, as I said. It also indicates, it gives you an audible and visual alarm to tell you when the blower discharge pressure is very low, you know, or when there is a abnormality in the discharge pressure. So this is quite very, very important for ships that have integrated bridge management system where all the alarms are linked together through the conning display. This type of alarm can actually give the duty engineer, in case, because we are doing a form of inerting operations, can take place all through the night. So it's very crucial. It's going to give them an alarm. So, and then they might call the engineer. In some cases, the deck officer or the chief officer also have the alarm panel in his room, and most of the cargo alarms goes to his room. If you're in a gas carrier, it goes to both the chief officer and also the cargo engineer. So it's very, very important. So another alarm that you can get, as I said earlier, is oxygen alarm. This is very common because I believe a lot of us here are tanker men. So when the oxygen content is high, you are going to have an audible alarm. And when it gets to a certain level, it can automatically shut down because it doesn't want to supply inert gas system with high oxygen content into the tank, which can actually lead to explosion. But one thing I want you to understand is it's not all systems that automatically shut down. You know, you have to set it. Sometimes wrong setting, you know, can lead to a catastrophic event. I.e., if you set the limit of oxygen content to be 9 by default, or you don't know. So what happens is you keep sending oxygen content that is up to 9, you don't know, and you don't know the implication. So it's very, very important for you to check the settings. And also these instruments or the analyzers, you have to calibrate it at regular intervals to ensure that they are working properly. It's very, very important. You have to calibrate it as per manufacturer instruction. Sometimes you just have to carry out a quick bomb or pump test to ensure that it's working well. So it's very, very important for us to know about the settings and the calibration. Another alarm that you receive again is about the dead water seal. You know, depending, some alarm can indicate low level and high level. So if you have the chance eventually to go on deck and have a look on the deck water seal, is always located forward over the accommodation, sometimes on the port side, on the starboard side, depends on the configuration of the vessel. So it's very, very important for you to check. There's a gauge level. It's just like in your car. When you open your car in the morning, there's a certain level you put water in the reservoir. And when you know when the water is too much, you know it's not a good indication. And when the water is too short, it can cause a bit of overheating. So it's very, very important for you to know the level. And this dead water seal alarm, you know, is an indication to tell you when the water is low, or when the water is high, or when the pressure of the water is low, or when the pressure of the water is high. So it's very, very important for you to know. All these alarms have their repeaters in cargo control room, and in modern ships, of course, the moment it gives you alarm, it also gives you alarm on the bridge. And in some ships also, when you receive such alarm, it comes as cargo alarm, and it gives a high set of alarm on deck. If you go to deck, you see different points fitted with all this alarm system. It all depends on the configuration of your ship. So it's very important for you to know your ship. But these alarms is generic, you know, it's tend to be homogeneous among all tankers. You know, the only difference might be, and like I say, settings is very, very important. So you also have another type of alarm is a deck inert gas, you know, the inert gas pressure on deck. So there's a certain amount of pressure. You need pressure to push the inert gas into the tank. Without pressure, it can't go in. So it gives, there's an indication when you have low pressure. So it gives you an indication, you know, that the pressure is low, the inert gas pressure is low. That means you need to increase the supply. The inert gas pressure is high. That means you need to open the vent riser and release some gases. And quite often, if you are in tanker, you want to take precautions while the vessel is alongside. So once you are loading, if there are lightnings in the vicinity, what you tend to do is to shut down the vent riser and sometimes reduce the cargo loading rate, you know, so that you don't generate so much inert gas to overpressurize the tank. So the moment you don't have lighting or water, then you can open or rain, you can open it, you know, and you can vent it out. So it's very, very important. So most of these alarms, some of them can automatically shut down the system because inert gas is a critical system. So it can automatically shut down the system. So the most important of the alarms is the control system, the entire system that control the inert gas system, you know, is like the brain box. So it's very, very important when you have a control system failure, it should also be able to give you an alarm because if it doesn't give alarm, it doesn't know that something is wrong. So failure of any of the automated control system power supply will indicate an alarm, because all these alarms, they are being fed by power supply. I.e., when you black out, normally most of these alarms are connected to an emergency diesel generator, and in some shifts to batteries. But what in some cases, there are some shifts that black out and emergency diesel generator refuses to start. So you get all this automated control system power failure alarm. So it's very, very important that as soon as you get this alarm, the duty engineer is being alerted to check, because of the importance of inert gas. Very important, I want to stress this. Before you commence crude oil washing, cowing, which is a very, very, you tend to do it at the end of loading, just to remove some of the sediment. And it's also a requirement, a MAPO requirement, that certain number of tanks should be crude oil washed every quarter. So apart from it's a requirement of crude oil washing, the IG, inert gas system, must be fully operational. All alarm system must be, because that is the case that you tend to get a lot of explosion, a lot of things tend to go wrong during crude oil washing. It tends to lead to, you can generate electrostatic, and when you don't have, when oxygen content is not low, it can lead to explosion, because now you have the fuel, you have the source of ignition, and you have the oxygen. So what is remaining now is just the disaster, So it's very, very important, So like I said here, it is recommended. It's not mandatory. This is a recommendation. If you go to SICTO, ISGOT, OCIMF, Intertanko, all the major tanker owners, all the major tanker operators in the world, it's just a recommendation that the IG oxygen content and the deck pressure indicator, which are the two keys, are being duplicated in CCR, and possibly also fitted in the bridge. And today, in almost all the ships, you still have an indicator. Even though it's not going to show you the IG pressure, you have an indicator in the bridge that shows you tank 1, tank 2, tank 3, if it's port and starboard with the IG pressure. And you have the main. When the IG pressure is high, and things like that. So it's very, very important, and it's very crucial that you familiarize yourself with these alarms. Okay, so inert gas procedure, general tank atmosphere control policies. Okay, so I've explained as we start the function of inert gas. But now, when do you use inert gas? You use inert gas before loading operations. For instance, after dry docking operations, or when a new ship is being built, the ship is in gas-free mode, or what we say is a gas-free state. It will contain oxygen of about 20% by volume. So, it depends. If the tank is not being opened, the oxygen might range between that. So what you do is you tend to inert the tanks, to reduce the oxygen level, below which it can support combustion. So inert cargo tanks should be inerted before loading, and they should also be inerted during the voyage at all times. The tanks should be in inert condition. During discharging also, as you are discharging cargo, you need also inert gas in the tank. So it's very important, like say also during cowing, crude oil washing, is very, very important for you to maintain an inert atmosphere. So tanks should be kept in an inert atmosphere, irrespective of whether they are in ballast state or they are in loaded passage, or you carry, because some tankers carry cargoes that are not combustible, so that might not require inert gas, i.e. if you are carrying palm oil cargo in a chemical tanker. So you have to look at the MSDS of that cargo and the special requirements, whether you need inert gas or not, because you should know inert gas is a dirty gas. So for instance, in LNG, you don't need inert gas all the time. It's only when you are preparing for a feed, or you want to come back and do gassing up and the rest. And when you are in normal loaded passage, is vapor. It's LNG vapor in the tank, so you maintain a positive pressure. So you can understand that different tankers have different peculiarity. Even some of the LPG tankers they have inert gas for that, but it's different. So it's very, 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 very important for us to know. So here, after cleaning and gas freeing, it is not necessary. It's not necessary to inert the tank. The reason, because when you clean the tank, you gas free the tank, you might have to maintain the tank, you might have to repair the tanks, you might have to check for cracks, or you might have to check the suction bell mount of the pumps. Is very, very important for you to know all those stuff that you need to do to prepare the ship for dock. But immediately, after you finish just operation and close the tank, you have to transit to an inert condition. So an inert condition, you have to inert the tanks, but very, very important, which is also a question that will come up during oral examination. You need to understand the flammable envelope. So as a tanker man, when you are inerting the tanks, you need to understand the flammable level. You need to know when to introduce inert gas, or below which you can support combustion. If you are gas free, which is very, very critical, you need to know when you reduce the hydrocarbon and then introduce the oxygen. So you need to also know the critical dilution line, which is very, 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 very important, So how do you inert the tank? You inert the tank in different ways. Let's say 2 different ways. You can either come through the dilution methods or the displacement method. Nowadays, people tend to use the displacement method. It all depends on your last cargo if you want to do displacement method. If inert gas is heavier, it can go down through displacement and you displace it. So it all depends on the type of cargo you carry, and the density of the cargo. The density of the vapor of the cargo goes a long way. So it's very, very important. In some ships, when you are switching over from gas freeing to inert condition, you might have to change some of the bends. Some of the bends have to go to different, you have to use some of the U-bend, you have to change some of the pipes. So it's very, very important for you to get yourself familiar with those type of system in your particular ship. Oil tanker A might be different from oil tanker B, so it's very, very important. So on completion of inert gas, normally you need to leave the inerting operation, you need to leave the tank, with a positive pressure, at least 100 millimeter gauge pressure. It's not it's not like this is the mandatory requirement, but it's a good practice of seamanship, So it's very, very important, So generally, when you want to gas free now, if you go to the IG, you still use the same IG generator, or you still use, but you have to change it from inert gas mode, inerting mode to gas free mode. So it's very, very important for you to know this. So generally, when the IG plant is shut down and the deck isolating valve are closed, that is when you are in dry dock now, because the IG system is short, the main isolation on deck is short, individual IG branch to all the tanks are short. The reason they are short is to prevent accidental opening of the valve, which might cause the inert gas to flow, and people might be working in the tank. It might lead to fatality. So it's very, very important, So during loading operation, close gauging is being used. That's for bigger tankers, but smaller tankers now still use open gauging, like the bunker barges that we're all aware, and some of them that are not really classed. They still use the open gauging. So this talks about ullaging, still during ullaging and dipping for sample collection. The tanks must be in inert conditions, is very, very important. So now, how many tanks are you supposed to open at a time? Somebody might ask, okay, you are inerting, will you inert one set of tanks? Will you inert 2 sets of tanks? Will you inert 3 sets of tanks? Well, it all depends. For instance, now, if you are already in inert condition and you need to, maybe you suspect that you have an issue in one of the cargo tank, maybe let's say cargo tank number 2, you can simply isolate cargo tank number 2 and that just go through that one. So you can do one tank at a time. It's very, very important for you to know that. It's not like it's a common, it's a common line, but you can do one tank at a time. So it's very important. And you should also know that all the tank openings and the vent must still remain closed when you are working on this particular tank. So this, I've said all this thing again already about the plant, Then you talk about the hydrocarbon content. It must be below at least 2%, to which it can support combustion. So it's very important. One of the major importance of inert gas is that it lowers the H2S content of cargo. For instance, if you go to terminal, i.e., I'll give you an example, some Escravos terminal, for say you go, they will say, okay, the requirement is the oxygen content must be below 5% and the H2S content must be below 50 ppm. Just an example illustration. So if the mooring master is on board or the surveyor and they inspected the cargo tanks and they find out that the H2S content is high, what they do is they ask the vessel to purge their tanks. What do you use to purge your tanks? It's inert gas system. You purge the tanks. What happens here is you lower the hydrocarbon content, to purge it. So that's one of the major functions of inert gas. Like I would say, tanks must be inerted before crude oil washing. Is very, very important. So one of the very, very important things for you to know is that, okay, to gas-free a tank, first, what do you need to do? Because this question quite at times comes out during orals. First of all, you need to purge the line with IG. What's the inert gas? What's the importance of purging the line? You purge the line to reduce the hydrocarbon content below 2%. So once you reduce it, I'm going to show you, it's going to go below the critical dilution line, because the moment you don't reduce this hydrocarbon and you start introducing fresh air, what leads is explosion. So that's why the first table, that's why I started by showing an analysis of accidents that has happened between 2004 and 2015. And when you look at it, some of them happened during gas freeing, tank cleaning, tank operation, crude oil washing. So now I just want you to quickly recap how important inert gas is. And then you have to follow the procedure. It's not just about you being saying, okay, this is the gas, but you have to follow the procedure. For instance, when we talk about the critical dilution line, you need to purge the tank first, ensure that the hydrocarbon content is below 2% that will support combustion. So it's very, very important. So like I talk about gas freeing. So when you are gas free, should be carried out by means of portable farm connected to pipeline. Yes, it comes all the way, use IG line for gas free. You draw fresh air generally, you use both IG line to supply inlet and outlet. And then as you are gas free, the inert gas, because you are displacing inert gas, so it's being vented through the vent riser. Sometimes you want to be fast, individual PV valves will be opened. So it's very, very important for you to know that. So when is a tank gas free? So a tank is said to be gas free, when the entire tank is found to have an oxygen of 21% by volume. So as you are quite aware, this takes us to enclosed space entry. So before you enter any enclosed place, be it a cargo tank, ballast tanks, hold spaces, anchor chain lockers, the atmosphere must be tested. First, before testing the atmosphere, one of the most important questions they ask during orals is for you to be able to know the instrument to use. We have different portable gas equipment. We have the Riken Kaiki, we have the MSA Altair, we have different equipment measure different component of gases, and you have to be very, very careful. Some of these things measure in percentage LEL, which is lower explosive limit, and some of the instrument measures upper explosive limit. Some of them measure in percentage volume. So you have to be extraordinarily careful when using this. Okay, so now an oxygen content of 21% by volume shows that the atmosphere there is gas free. And then not only that, you must be able to have a reading of 1% on flammable gas. If it is LNG, methane, 1% LEL. So it's very, very important. So, but now, what happens if you have toxic gases like benzene or hydrogen sulfide? Those gases, the moment you smell it, you are gone already. So what happened in the case of these gases, what you use, you test the threshold limit value. So some of them you use a Draeger tube, very important to test it. So before using the Draeger tube also, you have to check the type of Draeger tube. Some measure 0 to 10, 0 to 100, 10 to 50. And then you have to also see some of the Draeger tube, how many pumps are you going to give? Some will say to test for H2S, you have to give 10 pumps. So if you are not aware of it, you give 1 pump, it's going to be a false reading, and it can lead to a catastrophic event. So it's very, very important now for you to know the region of the world that you are before conducting, because of all this emission regulation. There are some places that don't allow you to vent in port. What they do is you connect. If you go to every ship, you have a vapor line. So you return the vapor to shore. So it's very, very important for you to know this. It's very, very important for you to know your cargo system piping. That is why even when you first join the ship as cadets, the first thing before you start shipping is line tracing in the case of tankers. So it's very, very important the atmosphere and when you vent to atmosphere. So there are different countries that have local regulations. So you have to be very, very careful. Okay, now in crude oil tankers, this is the last bit. There are some form of paraphoric deposit in inert gas, from inert gas. So what happened now, you should not allow this, because it's going to cause some sort of rust. It's going to cause some sort of certain reaction. So what happened now is you have to ensure that the inert gas that you are generating is of good quality to avoid this kind of paraphoric deposits. So the inert gas plant must be checked and ensure it's working perfectly. In short, if it means that a technician comes to check, is very, very important, because the quality of inert gas you send to the tanks, says a lot. You should try, rather than trying to prevent explosion, you might be exposing the ship to explosion. So it's very, very important. So, and if inert gas system fail, what happens? It's very, very important. Try and restore the plant as soon as possible. If you are discharging or if you are loading, the best thing is to suspend operation until the system is restored fully, because you can't continue without inert gas. So it's very, very important, very, very important component of tanker trade. So it's very important. So in product tankers, generally, very important, discharging should not begin or resume, without both parties agree. Even though when you have a failure, you go to ports like Japan, everybody will be there. So until both parties agree, they have inspected that everything is fine, the shore is ready. If you cannot have your inert gas plant running, then the shore can supply you with inert gas. So that has to be an agreement, is very, very important for you to discuss that during the meeting. So thank you very much. I've taken much of your time. I know it's supposed to be an hour. So by next Tuesday, we are going to talk about liquid cargo, if possible, with the permission of Captain Sobajo. We're going to talk about the LNG, crude oil, then possibly we have a section in crude oil washing, because quite at times, these MCA examiners, they tend to ask questions about the requirement for cowing. So there's a comprehensive book on cow procedure. So for your knowledge sake, you can also go through SOLAS. There's rich information about inert gas system. You can also go through the OCIMF publication on inert gas and flue gases. So thank you very much. I don't know if you have any question.
Thank you very much, Captain Danladi. It's too much juice, too much sauce, we're just enjoying the whole thing. There was a question in the chat from MA. He asked, is inert gas also necessary for bunker tanks?
Okay. For example, now, as you are aware, inert gas is a fixed firefighting system. So it depends on the type of bunkers. If it has a low, previously, before 2016, it was never a requirement for bunker carriers and all these ships. If I might get you a question right, is bunkering ships, you mean? The small bunker barges, right?
Yeah, I guess bunker barges and some vessels like in the offshore vessels, they carry bunker.
No,
yeah.
Yes, it's not a requirement. It's only a requirement when you are carrying low flashpoint cargo, and it's defined as cargo having a flash point of 60 degrees centigrade when you are doing a closed cup gauge system. So it's not a requirement. But if the moment you are carrying that particular cargo, because if you are supplying, you can supply bunkers that have different grades of oil. So I've inspected a lot of bunker barges and none of them is being fixed with IG system. They don't even have the IG generator. It's just a tugboat that will push the barge, and what happens is what they do is they open even the tank lid to vent out everything and for sampling. So, but in the case of ships of 8,000 gross ton that are carrying low flashpoint cargo, then is a requirement.
Thank you, sir. MC, yes, you can unmute yourself and ask your question.
Yeah, good evening, Captain. Actually, it's not a question. Mine is a contribution.
Thank you.
Okay. During the course of the lecture, there was this place Captain Danladi was speaking about as in he was talking about the times when you require the inert gas. And he said during transit, I just want to add that there are times when you're loaded 100% cargo in the compartment, you don't necessarily, as you do not have any haulage space where you can put, the inert gas has to occupy. So in that situation, there is actually no need for inert gas. Then in this requirement, this question that was asked, the bunker vessels do not require inert gas, but there are specialized vessels, like we have one in Nigeria, one MV Prince Job 1.
Yeah, I know the vessel, yeah, PJ1, yes. Yeah.
Yes, she has provision for inert gas because of nature of operation, but other vessels that are not, even tankers that are not up to this, the solar's requirements for inert gas is for tankers that are up to 20,000.
20,000.
Yes. Any tanker that is less than that, even though you're carrying PMS and the rest of them that have low flash point, you are not mandated to be fitted with inert gas. Thank you.
Okay, thank you very much for the wonderful contribution. One point I want to stress about your first contribution about if the ship is loaded and does not have space for oleaging, you have to make reference to solars, and then you know, the ship should never be loaded to a certain level of more than 98% cargo. So in that case, it can be a failed question in orals, because the requirement is that the tanks must be inerted at all time. I know a lot of us, we tend to look at you carry more cargo than, you know, but the safety is quite critical. So if it's a requirement, if you are less than 20,000, it's fine. But if you're up to 20,000, then the tanks must be inerted at all time. And if you are 8,000 deadweight tonnage and you are carrying a low flash point cargo, then you must be inerted. And I would strongly recommend that telling the examiner that you load a certain cargo, you don't have a real oleaging level, you know, he might have to take you back, you know, if you are in gas to IGC code and all those GC code, what happened to this construction on this. So you should know where you are heading to. And you will now say, okay, if you qualify now as master or chief officer, you are going to, you know, sail with an unsafe ship by loading cargo above that. We all know, but just for example, was this one. Thank you.
Thank you, sir. Umar, you can unmute and ask your question or add your contribution.
Okay, so mine is a question. I want to ask, he made mention of inert gas supplied from ashore. I want him to throw more light on that, please. I want to really understand the process and why and how it is formed from ashore.
Okay, there are certain terminals that don't allow you to vent. That is to vent first. So what you do is, you tend to do a vapor return. Sorry, I'm an LNG man, so I tend to call you have to do an IG return to shore. So if you look at the configuration of a tanker, there's one of the manifold that is highlighted yellow, and you see they'll put IG, right? So it's the same thing like when you are venting out through the vent riser. The only thing now, you isolate venting out through the vent riser, and it goes through the manifold. And what happens is the shore also connect their check stand for receiving your inert gas. That is in the case where you are loading cargo and you need to vent out IG, and is that particular geographical area, they don't permit such. So they provide you with a facility. Normally when they send that, they send it to a gas combustion chambers for burning. That's what they do. So the second one now is, if your IG system failed while you are alongside, and then you have made every possible effort to fix it, and you cannot, the next available option is, most of these terminals, they have inert gas system. Again, you connect your vapor manifold, and they send you inert gas system from shore. Just the way, you know, it goes through the inert gas line, and, you know, it moves all the way. So it's two ways. You receive and you can send. So I hope this clarifies your question.
Okay, so if it is sent from ashore to your ship, does it have to pass through the deck seal?
Through?
Your deck seal, the deck seal.
No, it's not going to pass through the deck water seal now, because the idea of deck water seal is to prevent the backflow of inert gas to engine room. So even if it comes up to there, it's not going to flow back.
From your manifold through your
manifold, you know, the yellow manifold, which is the inert gas manifold, it goes to the IG main line and to the branch valves straight to the tanks. That is how it's connected. You know, so there's a port. When I was in one of the CSC ships, I think it's around this Puerto Rico. I was told, I haven't been there, but I learned that they do that for receiving IG. But for the purpose of sending, theoretically, that is what they do, but practically, I've not experienced one.
All right. Thank you very much, Captain Danladi. I will share a little experience I have. One of the FPSOs we have offshore Nigeria as well, deep sea. They were engaged in offloading, discharging their cargo to a tanker, and they had problems with their inert gas system on the FPSO. I remember this very well because they had to request for gas from shore in special tanks to be brought, and I think they did not calculate enough. There were less one tank, and because of that, they had to send the vessel in again and bring inert gas again. The reason I remember this is because the electrician on my ship was supposed to go home for his wedding as soon as it was supposed to be like a 24 hours operation to offload this tanker, and we spent 8 days. So he missed his wedding day. And I remember that very well because there was an inert gas issue on it. I hope the lady will be able to understand, and all of us will understand the importance of inert gas. Any further questions, please?
I think in addition to that, Captain Sobajo, in Abu Dhabi and Dubai, when a ship is going alongside, there are barges now. They are like barges that supply inert gas to the ship. So in the ship, there is also, that is when you want to start, it can supply you instead of from the boiler. It can supply. So you have an uptake of inert gas from around the poop deck, or some, if you know where the power supply is, just by the pen locker, around the pen locker axis, you still have one there. So there are barges now, like they are more like barges that supply inert gas to ships that are going to dry dock, that don't want to run their inert gas system on completion of dry dock, and they want to go in inert atmosphere.
Is it the direct inert gas they supply you, or the flue gas?
No, it's inert gas, it's not flue gas. In Dubai, it's inert gas. When I was a chief officer in NLNG then, I went to Mogadis. What they supply us was nitrogen. On completion of dry docking, the tank was, they supply us with nitrogen to the tank from shore. Trucks were coming. And then when we went, we didn't have to do anything. We just did our normal extended cooling down, because at that point, you don't even need to gas up. So
yeah, because we use nitrogen on the LNGs for
yes,
primary and secondary barrier
space, exactly.
Yeah,
yes.
Space. All right.
But sorry,
I actually
really understand.
Yes, go ahead, please.
If the gas is supplied from ashore, how then does it develop pressure to work in the tank?
They have pressure is as the inert gas is supplied, right? Is you connect it, it comes like an uptake from the boiler. You understand? So all your fans are running, everything of yours is running. It's just going through the normal system up to the dead water seal, and the fan is giving you the pressure, the required pressure you need. Yes. So the difference now is the one that they are sending you from ashore, from the manifold. So they have to regulate the pressure to your tank, not you have to regulate. They have to regulate it to your tank.
Okay, so you don't have control over the pressure.
You don't have control over the one coming from shore. That's why you have to keep communicating. Okay, increase. Okay, reduce. Okay, you can stop. I have sufficient like this. Then they can stop. It's just like if you are in LNG trade and you are loading. Sometimes when you are sending gas, to this terminal during loading operation, they will tell you that please, you should reduce sending this gas. It's not sufficient. Otherwise, they will start flaring. You understand? So. So
yeah, good stuff. Thank you so much, Captain Danladi. We really appreciate this. We will be looking forward to liquid cargo. We're not gas for the whole session.
Captain, please, I have a question.
Yeah, please ask a question.
While receiving the inert gas, is it monitored from the CCR, or so that
Yes.
it won't go beyond what you're expecting or below.
That is when you are receiving from where? You have to be clear.
From shore.
No, when you are receiving from shore, you don't have, the only control you see is the inert. In CCR, you can only see the inert gas in your tank, you know, because you have sensors in the tank, and also the IG line pressure, you know, but the O2 and all those things is being monitored by shore. Mind you, in the tank, you don't have the analyzer. The analyzer is when you are producing and sending. So you have to have a very close collaboration between you and the shore. That is when you are alongside. But when they are supplying you, maybe after gas free, you are connected, you have control over everything because it's coming towards the engine room and you are the one sending it to deck. But this one, they connect the manifold, they just send it to you and it goes in. So they are terminal, they know the requirements, the similar requirement. OCMF is applicable to both of us, and you know, is God and everything you follow through. So during your ship shore safety meeting and then preloading meeting, all those things might have been discussed, you know, and agreed. So in case of IG failure, what do we do? What do we do? So it's very important. That's for that terminal. But for like terminal, like most of the terminal we do SBMs, that stuff is not really possible. So you have to suspend operations until the IG system is restored, or as Captain Sobajo said, they have to send another batch for them when they're in FPSO to bring inert gas, then you resume, you know, so it's very important.
All right, guys.
Thank you very much, Captain.
So
Thank you.
the application of inert gas ashore, is it the same application as the ship?
So to be honest, I know for terminals and tanker, you comply with ISGOD regulation, which is the same. That is as per ISGOD, because ISGOD is International Safety Guide for Oil Tankers and Terminal. So that is the same requirement for those. And mind you also, part of the solar requirement, they also stipulate among the OCMF is being extracted from solars. And OCMF also have to do with terminals. For instance, if you are in crude oil is a bit minimal in LNG trade, before your ship goes to a port, the assurance guy will need to go and carry out what they call the ship shore terminal assessment. They run the optimal, you know, and a lot of things. They send you questionnaires to fill and this thing. When you are doing, when you attend to do this OT inspection, SIRE, you know, is similarly. So technically, yes, it's the same requirement because it's ISGOD. It complies with tankers and terminal. So if you look at the new ISGOD checklist now, tankers, terminal have their own to fill. And if you check, one of the requirements is the oxygen content. So it's definitely the same requirement. But when it comes to when they are supplying you with, you know, alternative to inert gas, you can use liquid nitrogen or you can use nitrogen. So that is also different because if you check nitrogen in solars and coal, is not specified, but you know that nitrogen is a flue gas that doesn't support combustion. So the requirement, because it's nitrogen and you are supplying in form of inert gas, it has to be like inert gas, it's inert gas as well.
Captain, how about in your this thing fuel would like is inert gas necessary as well there?
Which of the fuel boats, like
where you store the main ship bunker?
Like I work in terminal and then I don't really understand how they handle their fuel for generators, but it doesn't have to, they don't need inert gas. Inert gas is a safety requirement on the ship. If you check in solars, inert gas is among the firefighting equipment, fixed firefighting, you know, is a requirement. So but for small bunker barges and small tankers, less than 20,000 deadweight, except you have 8,000 deadweight ton and you have low flashpoint cargo that you require inert gas. In such case, you don't require an inert gas system.
How about in depots where, like I remember some years back doing my internship, I worked as an intern as a safety intent. So I can't really recollect if the depot had any kind of inert gas fixed for their storage facility there.
No,
so I don't know if it is also necessary for there to be an inert gas in the cargo tanks in the in depots, like in storage facilities.
I don't really, because depot, they don't fall under marine, they are not covered under solars or ISGOT, because you should be able to know that there's a huge difference between a terminal and a depot. A depot is a land base for just storage, like they have tank farms, where tankers, like the petroleum tankers, they don't need IG. I don't think they don't have it. Permit me if I'm wrong, because I don't know much about the land transport, but they don't need IG. Is just what we are discussing here is strictly requirement by solars. So most of those are non-solars. For instance, now, if you have a warship, that is carrying fuel, it doesn't have to comply with the solars, because if you look at the application of solars is not applied to warship, to wooden craft, and some sort of pleasure craft. So even if those ones are carrying crude oil, there are how many thousand they don't have to comply, because this is a strictly solar requirement. They might just put additional safety measures.
They don't comply with. They don't even have some lines as well, So they don't comply with a lot of stuff. Yeah, that's fine. I think we need to round off now so that we prepare for next week. Thanks very much to everybody that's asked questions. All the tanker men, LNG men in the house as well. I hope we've had some good quality time. Next week, so guys, start reading something on liquid cargo. At least have some listing on it, and the upper one as well. So thank you again to everyone. Thank you, Captain Caleb, and it's a pleasure. I know I asked you last minute, but we always have you in mind. Thank you, guys. Thank you, guys. Have a nice day, everyone.
Bye. You too. Have a nice day and keep safe.
Yeah, thank you. Bye.
Thank you. Okay, bye.